Hello everyone. Uh, Today we are going to look at a case study. This is intended for the aerospace students of second year for their manufacturing technology course. We're going to look at the weight reduction and the cost savings through runner design in die casting operation. Okay, so let's get started. I am Dr. Ilangovan, Professor of Aerospace, SNS College of Technology, and thank you for joining me. So die casting is a process where it's a metal casting process, and it involves the feeding of molten metals into dies under high pressure and at high speed to rapidly create molded parts, whatever is the size shape of the in the mold. Now the main materials that are used in the die casting are the alloys of aluminum, magnesium, and the zinc. Only these three materials are possible or capable because their melting point is much lower than the container itself or the die. Now we will understand the topic where it says the reduction of the runners to bring down the cost. Now runners are what are runners? Runners are the horizontal um, channels that branch out from the sprue. This is sprue, and then you see here the material gets collected here, and from there it flows out to this actual component, that the die casted part that it has to be formed. Now the sprue guiding the molten metal to the molds. Runners may also be designed to feed the multiple mold cavities. This is a multi cavity mold where there are three cavities are there, and then the runners are designed in such a way that it will cater to all the three molds. Now, the biscuit is the word here which is being used. Okay, is the excess of the material that has been poured inside in the short sleeve of the cold chamber die casting. Now it is a part of the cast shot, and then the whole thing is removed from the die here. Only the part which is required will be used, and all the other parts, these are the extra parts, will be pruned off, and then they don't contribute to the actual production, but in a way, but they cannot be avoided also. Now, simulation is a process. Interestingly, then that is where our case study becomes. Is a place where these raw materials, the reduction of runner weight, and also the multiple cavities which are there. They if you try to save these kind of materials, you can bring down the inventory, the energy consumption, and the melting losses, especially in foundries offering the whole process chain for the casting production. All these extra things can be these materials which are being not just goes in directly into the making of the component. They can be reduced so that your productivity increases and the cost is saved. Now, this is a typical slide where I'm trying to show that the different types of defects that can happen in a casting, or even in a die casting. You have a misrun, you have a flow line cold shut, you can have shrinkage or the micro porosity, and these kind of, you can try and use some kind of a design improvement by positioning the geometry of the gate, the increases injection speed or the metal temperature, the die temperature, etc., and the effects you land up into a better quality. This one. Now that is the entire purpose of this simulation that has been tried out here. Now, so in a typical case study like this, where they have already must have used by ordinary methods, and then the study is done using a simulation software, and then you try to overcome the problems or you try to improvise a solution. Now, the object is the main purpose of this project was to reduce the runner weight of the part, which was already in production. So there has been a company, and for that company there has been a already the parts were being made, and then the runner weight was heavy, and so they wanted to bring it down. When they bring that down, you have to improvise the quality of the part plus the uh, plus the cost also comes down. Okay. The company which we are talking about is one the case study. This topic has been taken from the case studies that has been posted in the software of Magmasoft, and the company name is Kirpat from Bursa, Turkey. Okay. Now they are an OEM supplier, and then they are leading engine component manufacturers of automobile parts. Okay. They sell to they cater to Ford, Volkswagen, etc., and Renault. Now, using this software, MagmaSoft, the Kirpat investigated 5 different runners and gate designs. So it allows to iterate you on the various things before actually really making the different molds itself. In each design stage, especially the results from the filling, etc., can be simulated and found out. The simulation studies confirm that the casting could be maintained with runner designs, okay, that are having a smaller volume. Okay, so moving on, the outcome of the study shows that there is an increased yield, and then there's a smooth filling, and then the velocity of the flow was also much better. Now, when looking at the runner cross sections in the final design, it was observed that the velocity of the liquid metal increases proportionately to on the way from the biscuit to the gate, okay, and that the melt enters the cavity at a very optimum speed. And we can see the velocity results show an increase in velocity, which I just showed previously, and the velocity profile along the runner in comparison to the initial design. Now, this is the part, and then you see the biscuit here, and then the runners and the gate here. Now, there is an improvisation on the previous one, and the second one here. There is the improvised design, okay, and then you see the color the samples say that it is improvised, and the hot spots, etc., are not found. What was here is not found here. Now, the final runner design shows a reduction of runner to the total casting weight from 29.668%. That's a huge saving of material, resulting in the cost savings in many process steps. The they achieved weight reduction of the runner led to the opportunities to optimize the heat transfer by reducing the mold spraying time, and through the controlled solidification path to shorten the total cycle time. A cycle time is the time taken for the part to for the mold to get closed, and then the holding time, the injection time, holding time, and when the part is being taken out. That the entire thing to make one component or one mold, or if it is a multi cavity mold, one shot, is the one closure is what is the cycle time. Now, reducing the cycle time of a part with annual production of around 4 lakh units by 10% is highly advantageous, and it makes all the sense to reduce the runner or the optimize the runner. So here we see that the software has helped us to optimize the runner. Although the velocity changes in the runner during the filling yielded the desired results, the effect of solidification on the part quality also had to be taken into consideration. Definitely. Okay, the specific pressure was kept at 1000 to 1200 bar to obtain a sound casting which meets the porosity specification. In order to take the full advantage of the intensification pressure during the solidification phase, the runner branches were designed in such a manner to feed the last solidifying regions. That means the entire cavity has to be catered to. So these kind of trials can be tried out in the simulation software. Okay. The benefits of using software simulation not only maximize the production efficiency but also eliminated the areas in the mold that are thermally out of balance, and hence increase the mold efficiency. The defects can be initially found out, or the trapped air pockets or porosity or the hot spots, etc. All these can be found out in the simulation itself. Every advantage gained in the production helped the company, the secure part which we are talking about, to meet the increased customer requirements. And in the light of these, the challenging conditions, Magmasoft's contribution to the success of Kirpat's future cannot be ignored. And it is one advantage of the software that it contributes to the production and the reduction of the defects. Okay, so um, so this is the final part. You see uh, the the runner and the gate positions are highly improvised than the previous one, and you see the quality of the mold or is maintained. Plus, there's the reduction in the runner, which leads up to the cost saving. Thank you very much. We will meet once again on some other case study. Thank you very much. Stop. Well, let's stop here. Thank you.